Alright, now we're going to look at a couple of examples where we're going to find the information that I have listed there at the top. Now I did skip letter D because this actually follows exactly what you'll see in your textbook or in the homework, where I'm just going to ask that you do A, B, C, and E part. So first of all, we're going to do in behavior. So going back to using the same rules that we did earlier, your largest exponent, your n, is 4. Your leading coefficient, in this case, is an understood 1. So since this is even and this is positive, then I know that both ends of my graph are going to go up. So that would be A part. Okay, now B part, to find the x-intercepts, what you're going to want to do is take this and factor it. I do have a common factor of x squared. So that would leave me with x squared minus 9. And just like earlier, I told you, because we're asking also about touches, crosses, because that has to do with multiplicity, you will want to go ahead and factor with a difference of squares, x plus 3, x minus 3. Alright, when I solve x squared equals 0, then I am just going to get x equals 0, which means that I have an x-intercept at the point 0, 0. Then if I solve x plus 3 equals 0, I get negative 3, so I have an x-intercept at negative 3, 0. And then last, if I solve x minus 3 equals 0, I get x equal positive 3, so an x-intercept at 3, 0. Okay, now still going with B part, we have to do the touches or crosses, so we need to talk about multiplicity. So with the first one, the x equals 0, it came from x squared. Of course, this being to the second power means that I have 2 of those. So for this one, the multiplicity is 2, and since this is even, that means that it crosses. No, sorry, touches. Okay, for negative 3, that came from this factor, whose exponent is an understood 1. That's odd. We have crosses. X plus 3 came from the factor of x minus 3, again a multiplicity of 1. So therefore that's odd, and that crosses. Okay, now C part was to find the y-intercept. Now to find the y-intercept of any function, you just substitute 0 in for x. So that would be 0 to the 4th minus 0, 9 times 0 to the 2nd, of course, which gives us 0. So we substituted 0 in for x, and then we found y to equal 0. But if you have an x-intercept at 0, 0, your y-intercept is going to have to be at the same place. Now, what it means by additional points and maximum number of turning points, when we go to graph it, if we need to come up with some other points, we will. Let's go ahead and just state maximum number of turning points. So like in this case, make sure you state at most, because it's not going to be exactly. Now, at most, n minus 1 was like the formula. In this case, n was 4. So we'll have 4 minus 1, which is 3. So you'll have at most 3 turning points when you graph this. Okay, now let's look at graphing it. Okay, let's go ahead and mark our x-intercepts. And truthfully, we really don't have to have any additional points. We are just going to do a rough sketch of this. Keep in mind the end behavior and the touches and the crosses. Okay? Now I'm going to come back and I'm going to put a C, like real little, right here, and put a T right here. So I'll remember the 3 and the -3 is where it crosses. The T is where it touches. Now both ends have to point up. Since this is the last x-intercept on the left, like when your graph is finished doing whatever it's doing at this point, this end's going to have to go up, and this end's going to have to go up. That's what we decided. Now, as my graph comes down, it has to cross through this point and come to the other side of the x-axis. Now, it's going to have to come down and come back up because it has to come back here to the next x-intercept. So it's just dipping down and making a valley. Now, we're not going to worry about how far it dips down. I mean, we could use our calculator and get us some more points, but I told you a while ago we're just going to do a rough sketch. Now, it touches here. So as it comes down, comes back up, remember, touches means it comes in, touches, turns, and goes right back. Now, these are polynomials. Smooth, rounded curves. So you cannot come into this at a sharp point. You have to round it as you come through this point. Again, it's going to dip down. And we've got crosses, so I have to cross to the other side, which is going to put this end of the graph going up as it's supposed to. One thing that you would know that these two parts dip down the same amount is because the distance between these 2 points and these 2 points are the same. This was a unit distance of 3, this was a distance of 3. They're going to dip down the same amount.